Let us now talk about the combinations of resistors. So electronic devices often contain several resistors in their circuits to limit or divide a current or reduce or divide a voltage. So appropriate combinations or arrangements are applied to achieve the desired output. So arrangements could be that resistors are connected in series, resistors could be connected in parallel, or it could be a combination of series and parallel connections. So when resistors are connected end-to-end along a single path, they are said to be connected in series. So the resistors could be simple resistors, or they could be light bulbs or heating elements or other resistive devices. So for example, here, they're connected end-to-end. No, two light bulbs are connected end-to-end. There is a circuit formed. They are connected in series. So here we have, to represent that, to use the symbol for resistors are R1 and R2, which is equivalent to this. So the concept here, the principle here behind is that the current flowing through each resistor are equal. So supposing this is, this is R1 and R2 man. This is R1 and this is R2. So the current flowing through each resistor, so we have I1, I2, di ba? And then we have the voltage for each resistor. So current, meaning I1 equals I2, which is just equal to the total current flowing through the circuit. The total voltage is equal to the sum of the voltages of each resistor. So V sub T is equal to V sub 1 plus V sub 2. And the total resistance R sub T is equal to the summation of the resistances in each resistor. So you can add more depending upon the number of resistors that are connected in series. So, like for example, here we are to find the equivalent resistance. So supposing this is R1 and this is R2, R2, so the equivalent resistance R sub T is equal to R sub 1 plus R sub 2. And that is equal to 6 ohms plus 3 ohms, which is equal to 9 ohms. Then you're asked to find the current flowing through the circuit. So we have a voltage of 12 volts. So meaning I sub T is equal to V sub T over R sub T. So that's 12 divided by 9 ohms. And that is equal to, okay, that's 4/3, no? 4/3 ampere. Then you're asked to, then you will be asked, what is the current flowing through each resistor? So since the current flowing through a series connection are equal, then I sub T equals I sub 1 equals I sub 2, and they're all equal to 4/3 ampere. What is the voltage across each resistor? So V sub 1 is equal to I sub 1 R sub 1. So that's 4/3 ampere times the resistance R1 is 6 ohms. And that is equal to 8 volts. For V sub 2, that's I sub 2 R sub 2. So that's 4/3 ampere times 3. And that is equal to 4 volts. And diba, by principle, the total voltage is equal to the summation of all the voltages across each resistor. So 8 plus 4 is 12, which is equal to the total voltage here. But the question asked was just this one. Okay. And then we can also connect resistors in parallel. So when resistors are connected in parallel, the current from the source splits into separate branches or paths, meaning the current flowing through each resistor, they're not equal anymore. So for resistors in parallel, the total current is equal to the sum of the current flowing through each resistor. So meaning if we have 2 resistors here, then I total equals I sub 1 plus I sub 2. But this time, the voltage in each resistor are equal. So V total equals V1 equals V2. And the equivalent resistance, R sub T, the reciprocal of the equivalent resistance, total resistance, R sub T, is equal to the summation of the reciprocals of each resistor. So that's for resistors in connected in parallel. So here we are to find the equivalent resistance rather of these resistors connected in parallel. So we have R1 and R2. So the equivalent resistance 1 over R sub T is equal to 1 over R sub 1 plus 1 over R sub 2. So that's 1 over 8 ohms plus 1 over 4 ohms. So 1 over R sub T therefore is equal to 1/8 plus 1/4. That is equal to 3 over 8, 3 over 8. So finding the reciprocal, R sub T is equal to 8/3 ohm. So that is the equivalent resistance. You're asked to find the what is the voltage across each resistor. So we know that VT equals V1 equals V2, and they're all equal to 6 volts. Find the total current flowing through the cell. So the circuit. So I sub T is equal to V sub T over R sub T. So that's 6 volts divided by 8/3 ohm. So the current is 6 divided by 8/3. We get again flowing through each resistor. This is the current flowing through each resistor. So I sub 1 equals V sub 1 over R sub 1. And that would be equal to 6 volts divided by 8 ohms. So that would be 3/4 ampere. I sub 2 is V sub 2 over R sub 2. That is 6 volts divided by 4 ohms. And that is equal to 3/2 ampere. So when you add is 3/4 plus 3/2 equal to 9 over 4. When you add these two, is it equal to I sub T? The answer is yes. The summation of all the current or the current flowing through each resistor is equal to the total current. So 9 over 4. Okay, next. Resistors could be connected in a combination of series and parallel connections. So when we solve these connections, we are going to redraw the circuit after each combination. So combine resistors that are in series or in parallel. After that, we are going to redraw the circuit after each combination. And then we are going to repeat the first two steps until there is only one single equivalent resistor. And then we find the current on the single equivalent resistor and then work backwards through the diagrams to the original one to finding the current and the voltage drop across each resistor along the way. So for example, for this connection, we are to find the total current supplied by the battery, and we are to find the voltage between points A and B. So what we're going to do here first is to, when we don't have the labels for each resistor, so let's say this is R sub 1, this is R sub 2, this is R sub 3, and this is R sub 4. So we are going to work, 'di ba? We are to combine the resistors that are in series or in parallel. So let's start first with R3 and 4. So we're gonna redraw that. So this is R1, this is R2, but we're going to combine R3 and 4. This is now R3, 4. But since 3 and 4 are connected in series, so R3, 4 is simply equal to R3 plus R4. And that's 220 ohms plus 250 ohms. That's a total of 470 ohms. Ba? So we need to find the equivalent resistance first to find the total current man supplied by the battery. After which, we're going to combine R2 and R34. So drawing that again, this is R1, and then this is R2, 3, 4. But they're connected in parallel, so R1 over R2, 3, 4 is equal to 1 over R2 plus 1 over R34, right? So which is so R2, 3, 4 equals 1 over R2. What is R2 equal to? That's 180 ohms plus R34. I'm sorry, that is wrong. That's that's 1 over R2 plus 1 over R34. So this is 1 over 180 ohms plus 1 over 470 ohms. So R234 is equal to, what is that? 1 over 180 plus 1 over 470. Okay, that's a fraction, no? So it's 1692. 1692 over 13 ohms. And then we are to find na, let me show you, this is 24 volts. After which we combine R1 and R234 to get na the equivalent resistance. So R total is equal to R1 plus R234, which is equal to, what's R1 equal to? 110 ohms. So 110 ohms plus 1692 over 13 ohms. So the equivalent resistance is equal to 3122 over 13 ohms. So for letter A, the total current supplied by the battery I sub T is equal to V sub T over R sub T. So V sub T is equal to 24 volts divided by 3122 over 13 ohms. So the current is equal to 156 over 1561 amperes. 0.61 amperes. Okay, that is the total current supplied by the battery. Pila man na siya in decimal? That is like 0.1. So it's basically 0.1 amperes. And then we are to find the voltage points between points A and B. So our point A and B class is, diba, this is point A and this is point B. So basically we're looking for the voltage drop across 2, 3, 4. But since IT equals I1 equals I2, 3, 4, that is equal to 156 over 1561 ampere. So therefore, we can now solve for V234, which is equal to I234 R234. So that's 156 over 1561 ampere times R234 is 1692 over 13 ohms. And so V234 is equal to, let's multiply this to 1692 over 13. So that's 20304 over 1561 volts, which is approximately equal to 13.0070 volts. So this is the voltage drop across points A and B. Okay, next. Find the equivalent resistance between points A and C, and we are to find the current in each resistor if a 42-volt battery is connected between points A and C for this connection. So let's name the resistors. Let's say this is 1, 2, 3, and 4. Okay, so where do we start? So we can combine R1 and R2, and we can combine R3 and R4. Okay, so for R1 and R2, okay, R1 and R2, okay, R1, 2 is equal to R1 plus R2, right? Because they are connected in series. So that's 8 ohms plus 4 ohms. So that's a total of 12 ohms. And then for R3 and R4, they are connected in parallel. So R34 is equal to 1 over R3 plus 1 over R4. So that's 1 over 6 ohms plus 1 over 3 ohms. So how much is that? So computing, that's 1 over 6, your calculator, plus 1 over R34 is equal to, that's 2 ohms. So if we draw this again, combining now 2 and 1 and 3 and 4, so this is now point A. So this is now R12, and this is now R34. No, because we were able to connect them already. So we have 12 and 2. We have 12 and 2. So the equivalent resistance R sub T is equal to R12 plus R34. So R12 is 12 ohms plus 2 ohms. So R sub T is equal to 14 ohms. So that's our answer no, for letter A. Find the equivalent resistance between points A and C. So what is the current in each resistor if a 42-volt battery is connected between A and C? So the total current, this is for letter A. So I sub T is equal to V sub T over R sub T. So if it's 42 volts divided by 14 ohms, the total current flowing through the cell is 3 amperes, right? It's 3 um, amperes. So what's next? Okay, balik ta here. Since the total current is equal, no? I mean, the current flowing through a series connection are equal, this I sub T is equal to I12 rather. I12 equals I34. They're equal to 3 amperes. Okay? From this. And then, this R12 is a combination of R1 and R2. This R12 comes from, is equal to R1, R2, right? Therefore, I12 equals I1 equals I2, which is equal to 3 amperes. Okay, next. For R34, for R34, it actually comes from this R3, R4, right? R34 comes from, kaning R34 comes from R3 and R4, which are parallel to each other, meaning I34 is equal to I1, I3 plus I4. But how do we find I3 and I4 if we only have I34? How do we do that? We do that. Okay, balik ta sa voltage. So the total resistance here is 14. The total current here is 3. So I1 and I2, we now have 3. But for the voltage, total voltage is pila to 42 volts. But if connected in series, V sub T equals V12 plus V34, right? So we have 42 volts equals V12 plus V34. Now, what is the current, I mean the voltage across V12? And what is the voltage across V34? So since we have I34 and we have V34, 34, okay? Since V34 is equal to I34, R34, we can solve, right? How? V12, okay, V12 equals I12 R12. V12 is equal to 3 amperes times what is R12 equal to? R12 is equal to 12 ohms. So V12 is equal to 12 times 3, 36 volts. This is V12. So since we already have V12, we can now solve for V34. Okay? So V34 is equal to the total voltage minus V12. That is equal to 42 volts minus 36 volts. So V34 is equal to 6 volts. Okay? 6 volts. Therefore, what's next? If we already have 6 volts for total for this, meaning, di ba, voltage drop across parallel connection kay equal. So if V34 is 6 volts, therefore V3 is equal to V4. V3 is equal to 6 volts. V4 is also equal to 6 volts. Gagawin muna niya itong answer sa I1 and I2. So we can now solve for the voltage drop, the current flowing through R3 and R4. So I3 is equal to V3 over R3. Voltage across 3 is 6 volts divided by resistance 3 is 6. 6 ohms, meaning I3 equals 1 ampere. I sub 4 is equal to V4 over R4. So that's 6 volts divided by 3 ohms, then that is 2 amperes, I sub 4. So I sub 3, we already have answer, and I sub 4, we already have answer. Let's try to check. So since V34 is equal to I34, R34, okay, so I34 is equal to, sa to, V34 over R34. So V34 is 6 volts. And what is R34? R34, as we have earlier, is 2 ohms. Is 2 ohms. So therefore, I34 is equal to 3 amperes. So si I34 is equal to 3 ampere, it should be equal to I3 plus I4. I3 plus I4 is equal to 3 amperes. So therefore, this answer is correct. So these are the current flowing through each resistor here for this connection. Okay, next. How much current is drawn from the battery? So meaning we are looking for the equivalent, the total current, I sub T. So let this be resistor number 1, resistor number 2, and resistor number 3. So all we need to do here is to find the equivalent resistance to find the total current. So first we are going to combine 1 and 2. So R12 is equal to 1 over because they're parallel, 1 over R1 plus 1 over R2. So that's 1 over 500 ohms plus 1 over 700 ohms. So R12 is equal to that's 875 over 3 ohms. So after you find here the equivalent between R and 2, so this is R3, then it's now connected, no? This is now R12. They're now connected in series. So therefore, the equivalent resistance R sub T is equal to R3 plus R12. So that's 400 ohms plus 875 over 3 ohms. So R total is equal to 2075 over 3 ohms. So the current I sub T is equal to V sub T over R sub T, which is equal to 12 volts divided by 2075 over 3 ohms. So the current drawn from the battery is equal to, is very small, 36 over 2075 amperes. So na siya, that is the current drawn from the battery, or that's simply that's 0.017. Okay, so 0.07017 amperes, or that is approximately, if you're gonna express that in milliamperes, that's 17.3494 milliampere. Okay, so you can check. You can try to check the current flowing through each resistor here, and you can try to also the voltage drop across each resistor and check if it will satisfy the conditions for series and parallel connections.